While America has managed to build just 2 nuclear plants in the last half-century, China is racing to construct 150 in the next decade, redefining energy leadership and forcing the West to face a future it once abandoned out of fear. But this is not simply about power generation, it is the beginning of a global shift that could leave America technologically stalled and dangerously dependent, just as demand for electricity is set to double. How did the world's superpower surrender its energy future? And can it recover before China locks in nuclear dominance for generations? Electricity demand is entering uncharted territory. By 2050, the world's appetite for power will nearly double, driven by the explosive growth of artificial intelligence, electric vehicles, and industrial robotics. Every new data center, every electric vehicle charging station, and every automated factory line adds to the load. In the United States, the numbers are stark. To keep pace, the grid must expand by 50% by 2040. Yet current projections show the grid growing by only 20% over the same period. That leaves a 30-point shortfall, enough to stall the rollout of next-generation technologies and threaten economic momentum. The pressure comes from all sides. AI models demand enormous amounts of electricity to process and store data. Electric vehicles, expected to make up the majority of new car sales by the 2030s, will draw more power than entire cities do today. Robotics and automated manufacturing, too, require steady, high-capacity energy to run around the clock. The United States grid, once the envy of the world, now faces a future where demand races ahead of supply. Without a massive infusion of new, reliable baseload power, the promise of a fully electrified high-tech economy will remain out of reach. The scale of the coming power gap is not a distant worry, it is a present and growing constraint, shaping the choices and fortunes of nations. On March 28, 1979, alarms sounded at 3 Mile Island in Pennsylvania. A partial core meltdown unfolded, releasing a small amount of radioactive gas. No one died, but the headlines painted a different picture. Television anchors spoke of disaster, and public trust in nuclear power crumbled almost overnight. The fear spread quickly, fueling protests and new regulations that made building reactors in the West nearly impossible. 7 years later, the world watched in horror as Chernobyl's reactor exploded. The images of burning graphite and hurried evacuations from Pripyat became seared into the public mind. In the United States and Europe, nuclear power was no longer seen as a promise of progress, but as a threat. Politicians responded to the panic with stricter oversight and endless layers of bureaucracy. Investment dried up and the nuclear industry entered a deep freeze. Decades passed before any hope of revival. Then, in 2011, a tsunami struck Japan's Fukushima Daiichi plant. Even though the disaster was triggered by a once-in-a-millennium earthquake, the impact on Western policy was immediate. Planned projects were cancelled. Germany announced a full nuclear phase-out. In the US, the so-called nuclear renaissance vanished. The industry's momentum was stopped cold for another generation. But public fear and political backlash don't tell the whole story. While the West locked itself in debate over risk, China treated each accident as a technical problem to solve, not a reason to abandon nuclear energy. That difference in response would shape the global balance of power for decades to come. In the early 1980s, China's leaders faced a crossroads. The country was choking on coal smoke, and its rapid industrial growth left it vulnerable to energy shocks from abroad. Deng Xiaoping, the architect of China's modernization, set out a different path. Think in centuries, not just decades. Under his direction, nuclear power became a pillar of national policy, not as a gamble, but as a calculated investment in stability and independence. The government established state-owned giants like China National Nuclear Corporation and China General Nuclear Power Group, giving them sweeping authority to plan, build and operate reactors across the country. These enterprises were tasked with more than just construction. They were charged with building the entire ecosystem, From mining uranium in Xinjiang and Inner Mongolia, to running enrichment plants, to training engineers at top universities, every link in the chain was brought under domestic control. This approach stood in sharp contrast to the fragmented systems in the West. By the turn of the millennium, China had woven together a seamless supply chain that could deliver not just individual reactors, but entire fleets, designed, financed, and built by Chinese hands. The result was a nuclear program insulated from foreign shocks, capable of scaling at a pace the world had never seen. All of it was rooted in a single idea: national power depends on energy security, and energy security demands long-term vision. Watts Bar Unit 2 in Tennessee stands as a cautionary tale. Licensed in 1973, it did not deliver a single kilowatt-hour to the grid until 2016. 43 years passed, an entire generation, while the project stalled under shifting regulations, funding gaps, lawsuits, and endless redesigns. Construction paused for years at a time as public opposition mounted and government priorities changed. The Tennessee Valley Authority, once a symbol of American engineering ambition, became mired in bureaucracy and indecision. By the time Watts Bar Unit 2 finally powered up, its technology was already decades old and the cost had soared far beyond initial estimates. On the other side of the world, China's approach could not be more different. There, a new reactor moves from blueprint to full operation in about 5 years. State-owned giants like China National Nuclear Corporation run the show from start to finish: planning, permitting, construction, and operation all under one roof. Standardized designs and a vertically integrated supply chain keep projects on schedule. Bureaucratic hurdles are minimized, and the workforce remains active and experienced, moving seamlessly from one site to the next. In the time it took to complete a single American reactor, China can build and commission 8 or more. The numbers do not just tell a story of speed. They reveal a system built for execution, not hesitation. This efficiency gap is not about technology. It is about governance, authority, and the ability to act decisively when the stakes are high. Westinghouse Electric once stood as the gold standard of American nuclear engineering. In the early 2000s, the company secured contracts to build AP1000 reactors in Georgia and South Carolina. Initial projections for the Vogtle project put the cost at $14 billion for 2 units. But as construction dragged on, problems multiplied. Regulatory changes forced redesigns in the middle of construction. Shortages of skilled labor and a patchwork of subcontractors created bottlenecks. Each delay triggered new expenses, and the fragmented supply chain struggled to keep pace. Investors, focused on quarterly returns, grew anxious as costs spiraled. By 2017, the total bill had soared past $34 billion, more than double the original estimate. Shareholders demanded answers, but the math no longer worked. Westinghouse filed for bankruptcy, leaving unfinished reactors and billions in losses. The collapse sent a chilling message. Private investors saw nuclear as too risky, too slow, and too expensive to touch. In the US system, the drive for immediate profit clashed with the realities of building for generations. Hidden beneath the surface of America's nuclear stagnation is a vulnerability few want to acknowledge. The United States, once the global leader in nuclear technology, now depends on Russia for a critical step in its nuclear fuel cycle: uranium conversion and enrichment. American reactors require uranium fuel that must be processed before it can be used. But decades of neglect have left the United States without the domestic facilities needed to do the job. Instead, utilities sign contracts with Tenex, a division of Rosatom, to convert and enrich uranium for the nation's civilian reactors. This reliance is not just a technical detail, it is a strategic choke point. If diplomatic tensions escalate or sanctions tighten further, the flow of nuclear fuel to American power plants could stop overnight. There is no quick fix. Building new enrichment facilities on United States soil would take years and cost billions, while the skilled workforce that once managed these operations has largely vanished. As policymakers confront this reality, the stakes become clear. Energy security now rests in the hands of a geopolitical rival, exposing the grid and the economy to risks that cannot be ignored. Right now, China is set to generate more new nuclear power in 1 decade than the USA has in a half-century. As American grids strain and global influence shifts, the race is not about megawatts. It is about who sets the terms for the world's future. That contest is already underway.